Okay, so we're going to run through our milling machines. We have quite a few different milling machines, Gosford TAFE. So we're going to start with probably what is one of the most common types of machines you see in a lot of workshops, which is a small Bridgeport vertical mill. So the vertical mill gets its name because the spindle of the machine is running in a vertical position. If you'll note, we use a V-belt pulley arrangement to actually control the speed of the spindle on these machines. We also have a high and low speed, a brake up the top, and a 2-speed motor. You must take a lot of care when you're actually using these machines. When you change from high to low speed with the gearbox that's underneath the pulleys, you actually change the direction of the spindle. It's important that you're aware of this because one of the biggest problems we can have with our cutters is running them in the incorrect direction, which results in a lot of damage. So you have been warned, avoid running your cutters in the wrong direction. The parts of our vertical mill, we have at the back of the mill what we call the column. The column supports the bulk of the machine. We have a knee, sits on the front of the column on a dovetail slide. On top of the knee we have a saddle, and on top of the saddle we have our table. These machines, the table and the saddle and the knee, are all set perpendicular to the other slideways, so we can guarantee that we have a nice square plane to cut in when we actually move the table around. One of the things we need to get our head around when we're starting to use milling machines is what our base axes are. If you'll notice on our electronic readout, we have an X-axis, a Y-axis and a Z-axis. The X-axis on the machine refers to the movement of the table from left to right. The Y-axis of the machine refers to the movement of the table forward and back along the knee. The Z-axis of the machine refers to the knee moving up and down. Also on our heads for our vertical milling machines, we can actually move the spindle up and down. This is referred to as the quill of the milling machine. We can control this by using this lever on the side, which is very handy if we use the mill for drilling holes, or we can engage the feed using this lever, and this lever, which gives us good control and the rate at which the quill descends from the head. One of the things that's extremely important when you're using a vertical milling machine is to ensure the centerline of the spindle is square to the position of the table. If it's not, you can actually produce quite some unique shapes. But having said that, that is also one of the advantages of these type of machines. By tilting or moving the head relative to the X and Y and Z axis, we can actually produce some rather unusual shapes or cuts using our vertical milling machines. So, safety. We have our emergency stop. Ensure you're familiar with our controls on this. Start button, emergency stop button. You have a switch here which allows you to turn on the feed motor, a switch here for the coolant, and if you have a look at these two switches, we actually have a point where we can connect a slotting head to the back of the machine. This machine doesn't have a slotting head because we actually have a mill that's set up as a slotter. So that's the Bridgeport. Pretty common in a lot of workplaces. The Bridgeport uses an unusual means of holding the actual tooling in the spindle. We use an R8 taper, which is unique to the Bridgeport machine. Our next machine is the Konda. Very similar to a Bridgeport. We have belts in the top half of the machine to get my different speeds. Two-speed gearbox underneath the belts. Once again, if I change from high to low range, ensure that you have your spindle travelling in the correct direction. These machines have a two-speed motor, 1 and 2, and they have the associated speeds tabled on the head of the machine. We can use the quill controls on these machines as well, moving up and down. Same thing with our axis control. Our x-axis, our y-axis and our z-axis is up and down. This machine's been fitted with a reverse station down on the actual stop-start panel. Here we have our emergency switch to turn the machine off. We have a forward direction or a reverse direction. Once again, you must take care which one of the directions you're going to use. The purpose of this cap is to allow you to select which way you want your spindle to run, so your cutter's running in the correct direction, and once you've selected that, you can cover the other switch so you don't accidentally push it. This machine is fitted with a slotting head. Slotting head sits on the rear of the arm that sits on the top of the column of the machine. To start these machines up, we must ensure that I have the general power supply on, the feed box on, and my cooling pump on. There is a key isolator to stop people using the machine that have no idea what's going on. Once again, this is just a quick rundown on what you need to be aware of on the Konda machine. The Konda machine uses a standard milling machine taper, or an NT30 machine taper in the end of the spindle. And we'll be discussing that a little bit later on when we actually look at milling machines in a little bit more detail.